Hello everyone, this is Bhumika and today we are going to solve numerical data analysis semester paper. So let's begin. Question 1. Given a non-linear equation fx equals to x square minus x minus 1 equals to 0, apply various numerical methods to find its root. For any one of the numerical methods, bisection or fixed point iteration, perform the following task. A. Describe the algorithmic steps or present a flow chart for the method, clearly indicating initial conditions or assumptions, iterative formula or rule, stopping criteria, numerical results. Choose an appropriate initial guess or interval. B. Draw the flowchart for iterative calculations step by step. Tabulate intermediate result such as current approximation, function value and error at each iteration. C. Geometrical interpretation illustrating how the method approaches the root. D. Estimate the error at each step, absolute or relative, and demonstrate the convergence behavior and order of convergence of the method. Now answers of question 1. Solve fx equals to x square minus x minus 1 equals to 0 using the bisection method. A. Algorithmic steps, initial conditions or assumption. Fx equals to x square minus x minus 1 is continuous. Initial interval a comma b such that fa dot fb is less than 0, that is the function changes sign. Iterative formula, midpoint c equals to a plus b divided by 2. If fc equals to 0, root is found. If fa dot fc is less than 0, then set b equals to c, else a equals to c. Stopping criteria, fc is less than tolerance, that is 0.001, or b minus a in modulus is less than small epsilon like 0.001, or fixed number of iterations. Numerical result, choose initial interval 1, 2. Since f1 equals to minus 1, f2 equals to 1, so root lies in 1, 2. Iteration a, b, c equals to a plus b divided by 2, fc. Error equals to modulus b minus a. These are iterations, and after performing this iteration, root approximate 1.414, accurate to 3 decimal places. Answer of B. Flowchart, bisection method. Steps: start, input a comma b, tolerance, check fa dot fb is less than 0 while modulus b minus a is greater than tolerance. C equals to a plus b divided by 2. If fc equals to 0, that is root found, else if fa dot fc is less than 0, that is b equals to c, else a equals to c, and end. Now answer of C. Geometrical interpretation graph of fx equals to x square minus x minus 1 is a parabola. Root is point where the parabola crosses the x-axis. Bisection shrinks the interval around the root by having each time, usually pinching the root from both sides. D. Error and convergence. Absolute error b minus a, relative error c new minus c old divided by c new. Order of convergence, linear slow, error reduced by half each time. Up question 2. Estimate f9 using Lagrange interpolation. A. Assumption and formula. Given points 5, 150, 7, 392, 11, 1452, 13, 2366, 17, 5202, Now Lagrange formula for n plus 1. Now answer of B. Compute F9. We will use first 3 points of for degree 2 polynomial 5, 150, 7, 392, 11, 1452. Let's compute. Lx equals to y0 dot x minus x1 x minus x2 divided by x0 minus x1 x0 minus x2 plus y1 dot x minus x0 x minus x2 divided by x1 minus x0 x1 minus x2 plus y2 dot x minus x0 x minus x1 x2 minus x0 x2 minus x1. Substitute x equals to 9, that is f9 equals to 150 dot 9 minus 7 9 minus 11 divided by 5 minus 2 5 minus 7 5 minus 11 plus 392 dot 9 minus 5 9 minus 11 divided by 7 by 5 7 minus 5 7 minus 11 plus 1452 dot 9 minus 5 9 minus 7 divided by 11 minus 5 11 minus 7. Calculate f9 equals to 150 2 dot minus 2 divided by minus 2 dot minus 6 plus 392 4 dot minus 2 divided by 2 point minus 4 plus 1452 dot 9 minus 5 that is 4 9 minus 7 that is 2 divided by 11 minus 5 that is 6 11 minus 7 4 equals to 150 dot minus 4 by 12 plus 392 dot minus 8 divided by minus 8 plus 1452 dot 8 by 24, and the answer is 826 and estimated f9 value is 826. Now next answer the program. Def Lagrange interpolation x vels comma y vels comma x total equals to 0 n equals to len x value for I in range n term equals to y equals to value I for j in range n. If j not equal to I, term x minus x value j divided by x value I minus x value j. Total plus equals to term return total. X points equals to 5, 7, 11, y points 150, 392, 1452. Print estimated f9 Lagrange interpolation x points y point, 9. Now here is the graph, that is question D of question number 2. Lagrange interpolation versus actual data. Here is the graph comparing the Lagrange interpolated polynomials with the original data points. Red dot that is actual data values. Green curve Lagrange interpolation using the first 4 data points. Blue points interpolated value at x equals to 9, which is approximately 890.88. Numerical differentiation at x equals to 9 given data points. We will use Newton's divided difference interpolation to first form a polynomial and then differentiate it to estimate f9 and f-9. Here's algorithm. Step 1. Use Newton's divided difference interpolation to find the interpolating polynomial. Step 2. Differentiate the polynomial once for first derivative, twice for second. Step 3. Evaluate f-9 and f-9 or use numerical differentiation formulas for uneven intervals. For first derivative at a point x, f-x approximate summation of I equals to 0 to n of yi product of dli x divided by dx, where li x are Lagrange basic functions. Answer of B. Computation. First and second derivative at x equals to 9. We will take points around x equals to 9. Let's pick 5, 150, 7, 392, 11, 14, 1452. Use Lagrange interpolation and differentiate it. First derivative fx approximation using 3 points. Let fx equals to a x minus 7 x minus 11 plus b x minus 5 x minus 11 plus c x minus 5 x minus 7. Fx equals to a x minus 7 x minus 11 plus b x minus 5 x minus 11 plus c x minus 5 x minus 7. Using Lagrange coefficients and differentiating manually or via software like Python, we get f9 approximate 404.67, f-9 approximate 58.67. These are approximations using a degree 2 polynomial. Answer C. Error estimation. Truncation error. General form. For Newton or Lagrange method, error x minus x naught, x minus x1 to x minus xn dot f square n plus 1 error. We are using degree 2 polynomial for derivative estimation. Error depends on the third derivative. Can't compute exact error unless actual function is known. Estimate can be improved using 1 more points or comparing with 4-point version. Write algorithm for VD's rule. Input fx, input b, n dash b equals to n. Note, must a multiple of 6. H equals to b by n. Calculate step size. I equals to 0. Loop over intervals in groups of 6 for I equals to 0 to n minus 1 in steps of 6. Calculate points. X naught equals to a plus I minus h. X1 equals to x naught plus h. 2. X6 equals to x naught plus 6h. Apply VD's formula. I equals to I plus minus 3h by 10. F x naught plus 5f x1 plus f x2 plus 6f x3 plus f x4 plus 5f x5 plus f x6. Output approximate value of the integral I. Derivation of Simpson rule from general quadrature formula. General quadrature formula, that is Newton Cotes closed formula. Integral of fx from a to b equals to summation from I equals to 0 for wi fxi. xi equals to a plus ih, h equals to b minus a by n, b minus a by n. For Simpson's rule, n equals to 2. Integral of fx from a to b equals to w naught f x naught plus w1 f x1 plus w2 f x2 equals to w naught f a plus w1 f a plus h plus w2 f a plus 2h. Approximate minus 1 by 3 h plus 1 by 3 f a plus 4 by 3 hf a plus h plus 1 by 3 hf a plus 2h equals to b minus a equals b minus a by 6 minus 1 by 2 f by 2 a plus 4f a plus h plus 1 by 3 hf a plus 2h equals to b minus a by 6 f a plus 4f a plus h plus f a plus 2h equals to b minus a by 6. That is Simpson's rule. Now evaluate pi from integral from 1 to 0 dx 1 minus x square. Algorithm Gaussian quadrature method. Input function fx limit a comma b and number of nodes n. Get standard weights wi and nodes ti for given n. Transform nodes to actual xi using xi equals to b minus a by 2 into ti plus b plus a by 2. Evaluate fxi for all I. Compute I approximate b minus a by 2 Here's a simple algorithm and detailed solution to evaluate the integral 0 to 1 1 minus x square dx using Gaussian quadrature with n equals to 5. First, define the function fx equals to 1 by 1 minus x square. Second, transform interval a comma b equals to 0 comma 1 to minus 1 comma 1. Use the change of variable x equals to b minus a by 2 into t plus b plus a by 2, where t belongs to minus 1 comma 1, so x equals to 1 by 2 into t plus 1 by 2. Third, wi, that is standard weight, nodes, that is ti, for n equals to 5. Here is the table. Fourth, apply Gaussian quadrature formula. Integral a to b fx dx approximate b minus a by 2 summation from I equals to 1 to n for wi dot f b minus a by 2 ti plus b plus a by 2. Computation. Interval 0 comma 1 fx equals to 1 by 1 minus x square. Note, the function fx becomes undefined at x equals to 1, but Gaussian quadrature evaluates strictly inside the interval, so it's still safe. Let's compute values using xi equals to 1 by 2 ti plus 1 by 2. Then compute fxi and apply the formula. Using the 5-point Gaussian quadrature, integral 0 to 1 by 1 minus x square dx approximate 1.5708. This value is approximately pi by 2, so x approximate 2 into 1.5708 equals to 3.1416. Answer. Now question 6. Solve linear equations using pivoting plus direct method system of equations. X plus 2y plus 3z equals to 14. 3x plus 2y plus z equals to 10. 2x plus 3y plus 2z equals to 14. Step 1. Form the augmented matrix. Step 2. Apply partial pivoting. Identify the row with the largest absolute value in the first column to use as the pivot. Here, row 2 has the largest value 3. Step row 1 and row 2. Step 3. Forward elimination. Eliminate entries below the pivot in the first column. For row 2, multiply 1 by 2. Row 2 equals to row 2 minus multiplier into row 1. 0, 1.3333, 2.6667, 10.6667. For row 3, multiplier equals to 2 by 3. Row 3 equals to row 3 minus multiplier into row 1. 0, 1.6667, 1.333, 7.333, 7.333. Step 4. Partial pivoting for second column. Compare the absolute values in the second column below the pivot. Row 3 has a larger value 1.6667 compared to row 3 1.333. Swap rows 2 and row 3. Here's the result. Step 5. Eliminate entry below pivot in second. Column multiplier equals to 1.333, 1.66671, 66671.333 approximate 0.8 row 3 equals to row 3 minus multiplier into row 2. 0, 0, 1.6 and 4.8. That is answer. Step 6. Back substitution. From row 3, 1.6z equals to 4.8, z equals to 3. From row 2, 1.6667y plus 1.3333z equals to 7.3333. Substitute z equals to 3. 1.6667y plus 4.0 equals to 7.3333, that is y equals to 2. From row 1, 3x plus 2y plus z equals to 10. Substitute y equals to 2 and z equals to 3. 3x plus 4 plus 3 equals to 10, that is x equals to 1. Final answer, x equals to 1, y equals to 2, z equals to 3. Gauss-Seidel method algorithm. Start. Arrange the system of linear equations so that each equation is solved for a different variable, ensuring the coefficient matrix is diagonally dominant if possible. Initialize. Set initial guesses for all variables. Define the tolerable error. Iterative process. Repeat the following step until convergence. A. For each equation, compute the new value of the variable using the most recent values of the other variable. B. After updating all variables, check if the absolute difference between the new and the previous value of all variables are less than. C. If all differences are within the tolerable error, the solution has converged. Proceed to the next step. D. If not, use the new value as the current guesses and repeat the iteration. Fifth, output. Display the values of all variables as the solution. 6. End. Question 8. Write algorithm for Runge-Kutta method and give output for the ordinary differential equation d by dxy equals to 1 plus x plus y, y0 equals to 1. Find y1 in steps of 0.25. Given dy by dx equals to f x comma y with initial condition y x naught equals to y naught and step size h. The RK4 method computes the next value yn plus 1 as follows. First, compute the intermediate slope k1 equals to h dot f xn comma yn, k2 h dot f xn plus h by 2 comma yn plus k1 by 2, k3 equals to h dot f xn plus h by 2 comma yn plus k2 by 2, k4 equals to h dot f xn plus h comma yn plus k3. Update the solution. Yn plus 1 equals to yn plus 1 by 6 in bracket k1 2k2 plus 2k3 plus k4. Step 2. Apply RK4 to the given problem. We are to compute y at x equals to 1 with step size h equals to 0.25. Starting from x naught equals to 0 and y naught equals to 1. This requires 4 steps. First, x equals to 0 equals to 0.25, x naught equals to 0, y naught equals to 1, k1 equals to 0.25 into in bracket 1 plus 0 plus 1 bracket close equals to 0.5, k2 equals to 0.25 into in bracket 1 plus 0.125 plus 1.25 bracket close equals to 0.59375, k3 equals to 0.25 into in bracket 1 plus 0.125 plus 1.296875 equals to 0.60546875, k4 equals to 0.25 into in bracket 1 plus 0.25 plus 1.60546875 equals to 0.7138671875. y1 equals to 1 plus 1 by 6 in bracket 0.5 plus 2 into 0.59375 plus 2 into 0.60546875 plus 0.7138671875. Approximate 1.60205. Step 2. X equals to 0.25 equals to 0.5. x1 equals to 0.25, y1 approximate 1.60205, k1 equals to 0.25 dot in bracket 1 plus 0.25 plus 1.60205 equals to 0.71301. K2 equals to 0.25 dot in bracket 1 plus 0.375 plus 1.95855 equals to 0.83339. K3 equals to 0.25 dot in bracket 1 plus 0.375 plus 2.01875 equals to 0.84843. K4 equals to 0.25 dot in bracket 1 plus 0.5 plus 2.4505 equals to 0.98762. y2 equals to 1.60205 plus 1 by 6 in bracket 0.71301 plus 2 into 0.83339 plus 2 multiply 0.84843 plus 0.98762 approximate 2.44610. Step 3. X equals to 0.5 equals to 0.75, x2 equals to 0.5, y2 approximate 2.44610, k1 equals to 0.25 dot in bracket 1 plus 0.5 plus 2.44614 equals to 0.98652, k2 equals to 0.25 dot in bracket 1 plus 0.625 plus 2.9394 equals to 1.14109. K3 equals to 0.25 dot in bracket 1 plus 0.625 plus 3.0166 equals to 1.16041. K4 equals to 0.25 dot in bracket 1 plus 0.75 plus 3.6065 equals to 1.33913. y3 equals to 2.44610 plus 1 by 6 in bracket 0.98652 plus 2 into 1.14109 plus 2 into 1.16041 plus 1.33913 approximate 3.60087. Step 4. X equals to 0.75 equals to 1.0, x2 equals to 0.75, y3 approximate 3.60087, k1 equals to 0.25 dot in bracket 1 plus 0.75 plus 3.60087 equals to 1.33772, k2 equals to 0.25 dot in bracket 1 plus 0.875 plus 4.2698 equals to 1.53619. K3 equals to 0.25 dot in bracket 1 plus 0.875 plus 4.3689 equals to 1.56197. K4 equals to 0.25 dot in bracket 1 plus 1.0 plus 5.1629 equals to 1.79073. y4 equals to 3.60087 plus 1 by 6 in bracket 1.33772 plus 2 dot 1.53619 plus 2 dot 1.56197 plus 1.79073 approximate 5.39127. y1 approximate 5.39127. That is answer. Thank you and keep watching.